Swayam Prabha. Digital India. Educated India.
Hello, welcome to Introduction to Composites. Today is the 5th day of the ongoing week, and what we plan to do is have some discussion on thermoplastics as matrix materials, and also hopefully we will cover some other matrix materials such as metals and ceramics. So this is our overall scope of discussion, and we will start by discussing thermoplastic matrices. Thermoplastic matrix materials. By and large, thermoplastic matrix materials are used when we have short fibers. So this is in general, whenever we want, we have short fibers, we use thermoplastic matrix materials. Actually, maybe there is a better way of saying that. A lot of thermoplastic materials are used to make regular products, for instance chair, right, stool, ladders, parts of table, laptop covers and things like that. So, a lot of thermoplastics are used to make these day to day regular things, and in some cases the part may not be stiff enough or strong enough. So, what you do is that in those types of, so suppose you have a plastic chair, and most of these plastic chairs, they are made from thermoplastics. Okay. So, you want that chair to become stronger. So, what you do is you inject in that plastic some small short fibers, you do not put long fibers. So, that is what you do. So, that is known as you put some, typically you put some glass fibers. So, that is why I said short fiber applications. So, where they are used in applications which are in daily use. Chair, stools, laptop covers, ladders, okay, and things like that. These materials, even without fibers, the way you make these types of regular daily use product is in general through a method known as injection molding. Okay, you make it through an injection molding process. So, what you do, suppose you want to make a glass, which with some plastic glass, what do? You make a mold. So, this mold will have typically two parts. So, this is a block of steel, and then on that you will put another block of steel. Okay. So, what you have here is a cavity. This is the cavity. So, you have one block of steel, top block, you have bottom block, and I am giving you some basic idea, not the detailed description, and you have a cavity, and in this cavity you inject this plastic through some hole. So, that is why it is known as injection molding, and you send it at high pressure, and because it is a thermoplastic, you heat it, you melt it. So, you have high pressure molten plastic, and this plastic flows in and fills all the cavity, and then you let it cool, remove the top block, remove the bottom block, and you are left with that glass which you wanted to make. Okay. So, this is how it is made. Now, a lot of times if you think that this glass is not strong, or suppose you are making a chair, the chair is not strong, not only you inject this plastic, but what you do is, before you inject the plastic, you have this plastic, you also mix it. So, this plastic, raw material plastic, it comes in small spheres, okay, pellets, and if you want stronger material, you mix it with some glass, you mix it with some glass fibers, short fiber glass, and then you mix, and then you melt it, and then you inject that molten material, which is a mixture of glass and plastic, thermoplastic, into this, and you get this material. Okay. So, some of the very popular materials which are used in these type of applications are polypropylene, quite often it is known as PP, okay, polysulfone, polycarbonates, and there is a very popular material known as ABS, and this is a short form of a long name, acrylonitrile butadiene styrene. So, that is why it is ABS, this is ABS. So, in all these different types of material, you can also have nylon. All these materials you can mix glass, short fiber glass, because you cannot put long fiber glass, these are small pellets, and you cannot inject long fibers, otherwise this whole channel through which material is flowing, it will get blocked. So, you put short fibers and you press it. So, when the thing comes out, that product is stiffer and also stronger, and it can also take higher stress and higher temperature, because glass is stable at higher temperatures also. So, this is where a lot of thermoplastic matrix materials are used when we want to make short fiber composites. But there are some cases where we use thermoplastics with continuous fibers also, but there the process is totally different, it is not injection molding. Okay. So, one very important material is known as PEEK, and it is used in a lot of aerospace, naval applications, space applications. So, once again, what is it? Polyether ketone. This is a thermoplastic material, and the interesting thing about this material is that it can be used at pretty high degree temperatures, up to 310 degrees centigrade. So, a lot of our thermosets will not survive this temperature, but this can survive this 300 degrees temperature. So, here for aerospace applications, naval applications, a lot of times PEEK is used, and it is used in conjunction with long continuous fiber composites. Okay. It is used with long fiber composites. So, this is PEEK. So, PEEK, but here the process of production of the composite is not injection molding, it is something different. We will see that maybe next week, different ways of making the composite material. So, Finally, in context of thermoplastics, we will very quickly look at some of the material properties. So, again we will construct a table, a specific gravity. Okay. So, what are the properties? So, these are different materials: PEEK, polyamide. So, remember, polyimide and polyamide, they are different things. Polyimide is a thermoset material, polyamide, AMIDE is a thermoplastic. Then you have PPS, polyphenylene sulfide, polypropylene and ABS. So, specific gravity 1.3, 1.38, they are about the same, 1.3, but polypropylene, this is very popular material for day to day products, chairs, tables, glasses, because its density is very less, 0.91 polypropylene. And then ABS is about 1.06 to 1.08. The next material property is tensile modulus. And this is in MPa. So, 3300, 2800, 33, 1100. So, see, polypropylene, even though it is light, it is not that stiff, but for regular applications it works, and it is also very inexpensive. It is probably the cheapest matrix material available. Then we have tensile strength, again in MPa. So, tensile strength is 92, 95. So, polyamides and PEEK have similar strength. Then PPS is again 99, but then polypropylene would be very weak, 33, and ABS is more than that, 41 to 60. And the last thing I will write here is use temperature, max use temperature. Okay. So, this is where PEEK is very important, 310 degrees, 190, 260, 75, and this is 80 to 85. So, this is what makes PEEK distinctive. It can take a lot of high temperatures, and that is why it is popular in aerospace applications. So, that concludes our discussion on thermoplastics. Next, very quickly, in a qualitative sense, we will look at metal matrix materials. So, metals as matrices. So, here we will not worry too much about properties, because we have an idea that when we look at metals, they are several orders of magnitude stronger, stiffer than these plastics. So, why do we want to use metals as matrices? So, let us look at some of the important reasons. Strength. If we want to make things much more strong, plastics, they cannot provide a lot of strength by themselves. We have to only rely on fibers, but metals as matrices, they can provide a lot of strength. Stiffness, same thing. We use metals, they also provide a lot of stiffness. Toughness. What is toughness? Toughness is the ability of a material to absorb a lot of energy. So, these matrix materials which are plastic based, they cannot absorb a lot of energy, unlike metals. Impact strength. A lot of these materials are ductile. So when something hits at a high speed, they deform, and they can, once they deform in plastic, they can take a lot of energy because they are tough. So they have a lot of impact strength, but a lot of these plastics, when you hit them, first thing, they are not strong, and then they crack. So they don't take a lot of energy, absorb a lot of energy. So I will say use temperature. They have high use temperature, which can be several hundred degrees centigrade, and in some cases it can go up to 1000. And resistance to many environmental factors. For instance, UV radiation, you don't have to worry about if they are metals, but with plastics you have to worry about it. But then there are other things. Some metals react with oxygen, they react with air, they react with humidity. So we have to look at it. So this is, we have to look at it carefully. It's not a 100% true statement that they are resistant to it. It varies from metal to metal. So these are the advantages. But still, because of all these advantages, they are still not very popular. Why? So let us look at some limitations. Look at the limitations. One is processing temperature is very high, because if you want to make a matrix out of material, you have to melt it somehow. So the temperature has to be very high, right? And now at that high temperature, suppose do you want to mix it with graphite fiber, you have to make it inert, because at that high temperature if you mix it with graphite, graphite will also become hot and it will burn. So the atmosphere has to be inert. So processing temperature is high, so that is why the overall manufacturing of these types of materials is expensive. Density is high, so we may lose on the specific stiffness and specific strength. A lot of metals, they react with fibers. Okay. For instance, they may react with graphite and things like that. So we don't want that. And then we have corrosion. So these are the limitations. Now let us look at some examples for next 5-10 minutes. So we will look at some examples. So some of the most common materials which we use as matrices are based on titanium, or they are based on aluminum or aluminium. Okay. Density of titanium 4.5, density of aluminium 2.7. You don't want to use steel as the matrix material because it has very high density. So these are some of the lighter materials. We also have magnesium, and the density of magnesium is actually pretty low, 1.74. But then it has a problem. It reacts with oxygen, especially it burns very fast. Even if you heat it a little bit, it burns very fast and the whole structure can start burning very fast. Okay. So this is a limitation of that. Then there are some superalloys. So, and there you use metals such as cobalt, nickel for super alloy application. Where would you use them? Where you need strength as well as high temperature application, as in aircraft gas turbines where temperatures are very high. Okay. So can take high temperatures. Okay. So, this is there, and then these so these are some of the examples. Now, these metal matrices used to bind graphite. So, we do not use these for glass. Glass is a low end fiber, to bind either carbon fibers, okay. But then we have to make sure that a lot of these metal matrices, they react with carbon. So, if you bind them with carbon fibers, they react. So, for in that case what they do is they coat the carbon with something else, right, tungsten or something. So, here to reduce reactivity, carbon fibers are coated. With something which does not do that, and then they are also used to bind ceramic fibers. Examples is cements, we have discussed this earlier, and then we have some more examples. So, you have aluminum based materials. For example, there are two alloys, Al6061 and Al2024. These materials are used for high strength applications, especially in aircraft applications, okay, where you want high strength, you put graphite fibers and you use this. So, this here you add plus graphite fibers and you get real high strength. And you can the temperature could be as high as, so temperature use could be as high as 500 degrees centigrade, okay. But then again this graphite reacts with aluminum, so you have to coat it with some protective layer. And then we have titanium based materials, titanium based materials. So, again high strength to weight ratio, because titanium's strength is almost as high as that of steel, but its density is roughly half of steel. So, you really get a lot of strength. Use temperature can be as high as 500 degrees centigrade, okay. A lot of times you use these titanium based fibers with titanium based materials with boron or ceramic fibers, but again boron interacts, or silicon carbide fibers. So, again but you have to have protection against reaction, protect fibers reaction with metal, this is important, okay. And two examples of these titanium based materials. So, these are, you do not use pure titanium or pure aluminum, you use some alloy. So, one is known as TL alpha and the other one is known as TL beta. So, what do you have in TL alpha? You have, of course, titanium is there, but you have 6% aluminum and 9% vanadium, and in TL beta you have 2% iron and you have 3% aluminum and 10% vanadium. So, this is what you have. So, this is all about metal matrices, and tomorrow we will close this discussion on matrices by discussing two more types of matrices. One is ceramic based matrices, and actually so then the carbon based matrices, and then we will also have a small discussion on some additive materials. So, a lot of these composites, they are not just made up of matrix plus fibers, but we also add some extra stuff. So, we will talk about those things under the category of additives. So, that concludes our discussion, and we will meet once again tomorrow to have a closer on the discussion on matrices and additives. So, with that, have a great night, and I look forward to seeing you tomorrow. Thank you.